Hello class. We will continue our discussion on functional groups. And so the next functional group that you need to be aware of is an alcohol. And an alcohol has a generic structure like this. ROH. And the R group has to be alkyl. So some examples of an alcohol would be something like this. We could have a HO connected to a CH3. That would be methanol. If we looked at something like this, let's use zigzag now, 1, 2, 2 carbons, that would be ethanol. We could do 3 carbons and put the alcohol group there. Are you noticing how this R group can have many forms? It could be a methyl, an ethyl, 3 carbons, which is a propyl. So that R group can be anything alkyl. Now when you take a look at alcohols, they can come in many different shapes and sizes and whatnot. We could draw a benzene ring and stick an OH on it, and so this benzene ring is the R group, and we would call this molecule's name is phenol, and that's an alcohol. So you got to get very used to this. R group can be anything alkyl, and this ROH is just a general structure. Now, when it comes to alcohols, there's different degrees of alcohols. You can have a primary alcohol, a secondary alcohol, and a tertiary alcohol. So a primary alcohol looks like this. So if we take a look at ethanol, ethanol is a primary alcohol. And the way that we classify this as a primary alcohol is we take a look at the carbon that is directly attached to the oxygen. So you can see that this carbon here is attached to that oxygen there. And then we ask ourselves, how many carbons, so question mark, how many carbons are directly attached to that carbon? And so we see that there is 1 carbon attached. So if I look at another example here, what if I did something like this? Okay. No, not that one. Let's see here. What if we had like a carbon chain like this here, and we put the oxygen there, the alcohol right there? So when we take a look at this, we see that's the carbon the OH is attached to. So we're counting how many carbons are directly attached to that one. And there's only that carbon. So that makes that a primary alcohol. Now what if we have an alcohol that looks like this? What degree of alcohol is that one? Well, it's the same process. We identify the carbon that is directly attached to the oxygen atom, and then we find how many carbons are directly attached to that carbon right there. So I see 1, 2. So this alcohol is a secondary alcohol. Now what if I had an alcohol that looked like this? like that. What type of alcohol is that? Same process. That's the carbon that's directly attached to the oxygen. And now we ask how many carbons are attached to that carbon. 1, 2, 3. So that makes that a tertiary alcohol. So we have primary, secondary, and tertiary alcohols. And I want to emphasize that this is very, very important for you to be able to identify, because as you progress through the course, depending on the degree of the alcohol determines how it's going to react. So you need to be able to identify the degrees of alcohol so you can predict their reactivity. So this is very important to understand and to know. So the next functional group that we want to take a look at is called ethers. So an ether also has an oxygen atom. And this is an ether, where you have an oxygen atom sandwiched between two alkyl groups. So the R groups have to be alkyl, they can't be hydrogen. Because if they're hydrogen, let's say if this R group was a hydrogen, what would we get? We would get an alcohol. So the R groups here for ethers has to be alkyl. So you can have an ether like this, 1, 2 carbons, 1, 2. And you can see that these 2 carbons is this R group, and these 2 carbons right here are that R group. And you can see that the 2 R groups are exactly the same. They're 2 carbons, so ethyl groups. And when you have 2 groups that are exactly the same, you have a symmetrical ether. Is symmetrical spelled with 2 M's or just 1? I'm the world's worst speller. We'll just go like that, okay? Symmetrical. But then you can have an unsymmetrical ether, so something that looks like this. You can see this R group is a methyl, and then this R group is 1, 2, 3, 4. So 4 carbons. It's unsymmetrical. So ethers. Now ethers can also be in a ring. So you could put, let's say, an oxygen like that. That's an ether. But when you have an ether in a 3-membered ring, we call that an epoxide. When you look at that epoxide, you can see how this carbon right here could be this R, and then that carbon right there could be that R. So we have an oxygen that's sandwiched. We have an oxygen that's sandwiched between 2 carbons. Okay, so those are ethers. We have something that's very similar to ethers called thiols. And thiols are just replace the oxygen with a sulfur atom. So we could have, sorry, I misspoke. So if this is an ether, and if we replace that oxygen with a sulfur atom, like that, what we have is called a sulfide. Sulfide. Okay. So you can have symmetrical sulfides, like that, and you can have unsymmetrical sulfides. Right? So what we have here, so that is sulfides. But then what, remember this functional group right there? What's that functional group right there? That is an alcohol. So if we replace the oxygen here with a sulfur, now we have a thiol. No. Get this. There we go. So there we have a thiol. So you take that R, and that's going to be alkyl right there. So we could have thiols. Just look at all the examples of the alcohols that I've done and just replace the oxygen with the sulfur and you'll get thiols. So this is a thiol. That's a thiol. Okay. Another classification that we have, and I'm going to just introduce this functional group. Just checking to make sure this is still recording here. Is benzene. Okay. Now we have benzene here. All right. So that's benzene. But when you have a benzene molecule, it follows or falls under the functional group called aromatics. And what that's talking about, aromatic compounds are typically in a ring structure, are in a ring structure with double, single bonds, alternating bonds. And so at this point in the game, all I want you to understand is that benzene is an aromatic compound. And we will learn in the future other different types of aromatic compounds. Okay? I just want you to be aware of that. Benzenes are aromatic compounds. Okay? Okay, the next functional group that's really, really important and is something called a ketone. So a ketone has a generic structure like this, where what we have is the R groups, okay? The R groups have to be equal alkyl. The R group has to equal alkyl. And then you have another functional group which is called an aldehyde. And an aldehyde has at least one of these R groups is a hydrogen. So you can have both of the R groups here. They both could be hydrogen, or at least one of them has to be hydrogen and the other's alkyl. So when we take a look at a ketone versus an aldehyde, the major difference is that in a ketone, both R groups are alkyl. So if I draw a very simple ketone, acetone, like this, acetone is a solvent that most people have seen it as nail polish remover. So that is acetone, and that is a ketone. because both R groups are alkyl. Now you could then look at something like this, where we have two H's. That is a aldehyde. And this one is called formaldehyde. And that's embalming fluid. Another aldehyde could look like this. You see one of the groups is hydrogen, one is alkyl. That is also a aldehyde. Now when we look at our aldehydes and ketones, you can see that both of them have a carbon double bonded to an oxygen. You see that? So that carbon double bond oxygen right there has a name, that little piece, and that's called a carbonyl. And so we have a carbonyl in an aldehyde and a ketone. What makes it an aldehyde or a ketone is dependent on what goes here. Hydrogen is going to be aldehyde, two alkyl groups is going to be a ketone. But both functional groups have a carbonyl. And carbonyls are simply just a carbon double bonded to an oxygen atom. Now you got to be very careful though when you look at aldehydes, because we have a hydrogen directly bonded to a carbon. So organic chemists don't need to show it. Well, formaldehyde's a little tricky. So formaldehyde, we'll make that an exception. But let's say this aldehyde right here. This aldehyde right here could be drawn just like that. That is an aldehyde. And you know it's an aldehyde because there has to be that hydrogen right there that's not drawn. So if I draw a molecule that looks like this, and then just go like this, what functional group do I have there? Well, that molecule is a aldehyde because there's this unwritten hydrogen right there. So that is an aldehyde. Got to be aware of that. Okay. Now, what if I took this molecule and put a double bond O there? Now what do we have? We have a ketone. And you can see that this ketone is symmetrical because there's 3 carbons there and 3 carbons there. So that's a symmetrical ketone. And so you can envision an unsymmetrical ketone that looks something like that. We have a methyl here, CH3, and then an ethyl right there. Pretty slick. Okay, so let's take a look at another compound that has a carbonyl in it, but is not a ketone or an aldehyde. It is actually a carboxylic acid. Well, let's take a look at a carboxylic acid. Carboxylic acid has a R group like that. And the R group right here can be a hydrogen or alkyl. And so that is a carboxylic acid. Now notice in the carboxylic acid it has a carbonyl. So examples of carboxylic acids, just replace the R group with a hydrogen or an alkyl group. And when you're doing alkyl groups, they can be anything really. So the sky's the limit. So a quick example of a carboxylic acid could be something that looks like this. We have 2 carbons for my R group, my carbonyl, and then the OH. And it's this OH that's directly attached to the carbonyl carbon makes this a carboxylic acid. Another functional group also with a carbonyl is something called an acyl chloride, or an acyl halide. And an acyl halide has a general structure like this. Where the X right here can be any halogen. Typically, the acyl halides that we typically see are going to be like chlorine, bromine, and iodine. And so now it begs the question then, what is an acyl group? Okay. So let's just recap here. What is this group right here called? That's called a carbonyl. That's supposed to be a Y. Carbonyl. But when this R group right here is alkyl, let's redraw this here. All right. This piece right here we call that an acyl piece. Oh, goodness. So that is called an acyl group. And that's when the R equals alkyl. So we can have acyl chloride. So if I say an acyl chloride looks like this. We would replace the X with one of the halogens, the chlorine. And then you could say, hey, well, what is that R group? Well, the R group could be anything, alkyl, right? We could tack on some carbons here, just anything. So that would be an acyl chloride. Okay. But generally speaking, this structure right here is called a acyl halide. Okay? So let's take a look at another functional group called anhydrides. So an anhydride is a compound with a carbonyl. But now what we do is, you see how that right there is a carboxylic acid. But if you take that carboxylic acid and replace that hydrogen with something that's attached to a carbon, and not only just a carbon, but a carbonyl carbon. So if you take two acyl groups and sandwich them between an oxygen atom, that is called an anhydride. And oftentimes textbooks will call it an acid anhydride. So I use both interchangeably. anhydride or acid anhydride. It doesn't really matter to me as long as you get that word right there. Anhydride correlates to that structure, then you're going to be good to go. Okay? So the R groups right here can be hydrogens or alkyl. Those alkyl groups, if you make these alkyl groups and they're exactly the same, then you have a symmetrical anhydride. If the two R groups are different from one another, then they are going to be an unsymmetrical anhydride. Now, let's take an R. All right. So what is this group right here? I hope you're all saying carboxylic acid. Now, what if I took that hydrogen and replaced it with a R group? And this R group has to be alkyl. If it is alkyl, then what we have made is a ester. Don't confuse esters with ethers. An ether is this. An ester has a carbonyl group. Now, why is this so important? To say that this R right here, right? That R right there. So let's distinguish that. So we will call this R1, okay? R1 has to be alkyl because look at what happens. If I put a hydrogen in for R1, what do I get? It's no longer an ester. It is a carboxylic acid. So that is why R1 has to be alkyl. Okay. But this R group here on the left side, this guy or this guy, that can be a hydrogen if you'd like. But typically you'll see them as alkyl groups. But this one for sure has to be alkyl. Okay. And so you would see what would be an example of a ester? Well, you could have a methyl group, something like that. That would be an ester. Do you see right there? That is a alkyl group. So that makes that an ester. Now you can also have cyclic esters. Right. So we could take a ester and put it in a ring. So you could take a ring like this. All right. So the way I drew this molecule right here, what would the functional group be called? What would you think? What do you think? That drawn there is a ether. But the moment I put a carbonyl on it, and that oxygen's directly attached to the carbonyl, and then directly attached to this oxygen is a carbon, which is a alkyl group. Do you see how this structure right here fits, or this structure right here fits that definition? Because this R group right there is that guy, and then that R group right there is that guy. So we have a cyclic ester. And cyclic esters have another name. They're called lactones. So we have lactones are cyclic esters. Okay, we have two more functional groups that I would like to talk about. Now these sound very, very familiar or similar to one another and can often lead to confusion, but I'm hoping that you will pay close attention, that you can see that there's going to be a difference here. We have something called amines and amides. You see how they're spelled differently, okay? But an amine is simply where you have a nitrogen atom, right, connected to groups. And these R groups right here can be hydrogens or alkyl groups. And that is an amine. Amides are simply, if you take a carboxylic acid and you replace that oxygen with a nitrogen. And nitrogens have to have at least 3 bonds, so you could have R groups like this. And in this, the R groups can be hydrogens or alkyl. So do you see the difference? An amine has no carbonyl carbon, whereas an amide has the carbonyl group right there. So you could have amides that look like this. They could all be carbons, or you could have any variation. You could have 2 hydrogens, or you could have all hydrogens. Each one of these structures right here is an amide. Now, let's focus our attention on amines for a moment. Do you recall when we looked at alcohols? We could have primary, secondary, and tertiary alcohols. And you recall that it depended on how many carbons were attached to that carbon. So that would be a primary. That one would be a secondary. And that would be a tertiary alcohol. Amines also can have a degree system. So amines could be primary, secondary, tertiary, and there's a 4th degree called quaternary. But when you look at an amine, okay, that amine right there, the protocol for determining the degree of this amine is really, really simple. You count how many carbons are directly attached to the nitrogen atom. So when we look at this amine right here, how many carbons are directly attached? 1. Do you see what I mean? I hope you see what I mean by directly attached. This carbon is bonded to this nitrogen. This carbon right here at the very end is not directly bonded to the nitrogen. That carbon is bonded to that carbon. So this would be an example of a primary amine. What if I drew this guy? What degree of amine is that? How many carbons are directly attached to the amine or the nitrogen? 1. So this is also a primary amine. But what if I changed it up a bit? And let's put a carbon right there. Oh, that doesn't look good. What? Let's do it. Let's draw it this way here. Okay. What is the degree of this amine? Well, there's this carbon directly attached and that one. 2, so that makes that a secondary amine. And can you see what's going to happen here? What type of amine is this? Well, that's a methyl. That's a methyl, and that's a methyl. So that's 3 carbons directly attached. So that would be a tertiary amine. Now you could have an amine with 4 groups attached. Okay. And if the 4 groups right there have carbon attached, that would be a quaternary amine. Now when an amine has 4 bonds and no lone pairs, this guy is going to have a formal charge of a +1. All these amines right here all have a lone pair. Like so. And these oxygens have 2 lone pairs. So we have primary amines, secondary, tertiary, and quaternary amines. And the reason why this is so important is the same reason that we talked about with the degrees of alcohols. You need to be able to look at an amine, calculate its degree, and that will determine how it can react or if it can react at all. The degree matters. But the way we calculate the degrees of amines are slightly different than the way we calculate the degree with alcohols. Okay? Okay, those are the functional groups that you need to know. It is imperative that you know how these functional groups look. And being able to look at a larger molecule and to pick out functional groups is an essential skill. And then as we progress in the course, we are going to learn the nomenclature of these functional groups. We're going to learn how to name these alcohols, and name these amines, name these carboxylic acids. Right now, we're just giving you the general name, the general structures, so we can all be on the same page. When I point to this, we can all say, hey, that's an amine, that's an alcohol. But as we progress, we are going to be like, okay, this alcohol is this, and this is an alcohol, but this one's ethanol, and this is isopropyl alcohol. So, like, there's a difference between them, right? So, that's where we're going to stop for today. And as always, if you have any questions or concerns, please feel free to reach out and we can discuss it.